In this video, we will explore the properties of similar polygons, and we will use those properties to find unknown sides and angles. Whenever you are dealing with similar polygons, there is always a scale factor. And I always describe the scale factor as a new length divided by the old length. New over old. It's usually arbitrary which one you consider to be the new shape and which one you consider to be the old shape. I will usually pick the smaller shape and I will call that the old shape. I think of it as the original, and it's been blown up, expanded to become the new shape. But you'll get the same answer no matter which one you pick. But always do new over old. So you can use the scale factor because if you have similar polygons, new over old should equal new over old. So you can easily set up a proportion. I'm going to go ahead and call this x instead of question mark. So I need a pair of corresponding sides that I can use to do my new over old. So of course it is clear that these two are corresponding sides. They're all oriented the same way. So those are definitely corresponding sides. So if I make a fraction out of those in the form new over old, that would be 24 over 20. So I have 24 over 20. Now, if I pick another pair of corresponding sides involving the variable that I'm looking for, that would be these two. And again, I will set up my fraction in the form new over old, so I will do 30 over x. So I could cross multiply right now. However, I like to reduce my fractions before I cross multiply. You don't have to, but I like working with smaller numbers better. So if I have 24 over 20, that reduces down to 6/5. So I will think of this as 30 over x is equal to 6 over 5. And then now I will cross multiply by doing multiplying this diagonal and then multiplying this diagonal and setting those equal to each other. So looking at the blue diagonal, I have 6x equals. Looking at the yellow diagonal, I have 150. Then I need to divide both sides by 6. And that's 25. Alright, so that's the unknown side for problem number 1. So we will do the same thing for problem number 2. Let's see, corresponding sides. I see that I have a pair of corresponding sides here and here, so I can use that. Let's see, I will call this the old and I will call this the new. Okay, so here I go setting up my fractions. Let's see, I think I'll use this space over here. So once again, I'm doing new over old is equal to new over old. So 35 over 28. And now I need my other pair of corresponding sides involving whatever it is I'm looking for. New over old, so that's going to be x over 20. Alright, so this is really the same type of thing as problem number 1. 35 over 28. That's 5 over 4. Okay, so if I cross multiply once again, Alright, multiply the yellow diagonal, multiply the blue diagonal. Then I'm going to get 4x is equal to 100. And then if I divide both sides by 4, I come up with x is equal to 25. So that is the unknown side for problem number 2. Okay, for problem number 3, I'm going to have some algebra to do. I will consider this polygon to be the old, and I will consider this polygon to be the new. So once again, I'm going to set up my proportion by doing new over old is equal to new over old, like I always do. So these are corresponding sides, so I'm going to definitely do new over old. So I'm going to do 8x minus 10 over 30. Now for my other new over old, I need to scroll down to snatch up this extra information. The scale factor from A to B is 3 to 7. Okay, so I'll just sneak the scale factor in here. So 3 to 7. Okay, so I can just straight use that as my new over old. So I will do 7 over 3 using the scale factor. And then I'm ready to go. I can cross multiply. So I'm going to do I will multiply the yellow diagonal, and I will multiply the blue diagonal. Multiplying the yellow diagonal, I have 3 times 8x minus 10 equals. Multiplying the blue diagonal, I have 210. So I need to distribute this, so that'll be 24x minus 30 is equal to 210. And then we'll add 30 to both sides. So that'll give me 24x is equal to 240. And then if I divide both sides by 24, that's going to give me x is equal to 10. Okay, and solving for x, that's what we're supposed to do. So that's it for number 3. Alright, I'm just going to do the same thing for number 4. So I will consider this to be old, and I will call this one new. Now I could have done it the other way, it doesn't really matter. But when I set up my proportion, I like to do new over old is equal to new over old. Okay, so looking at these corresponding sides, new over old, so that's going to be 3x minus 45 over 6. Now for the other ratio, I'm going to use the scale factor that they gave me. A to B, that's 2 to 3. So, okay, so A, that's the 2. And B, that's the 3. So there's my scale factor, 2 to 3. Alright, but when I write my scale factor into my proportion, I'm going to do new over old. So I'm going to go ahead and do 3 over 2. And then I am ready to cross multiply. So I'm going to do my multiply the yellow diagonal, and then I will multiply the blue diagonal and set those equal to each other. So I'm going to do 2 times 3x minus 45 is equal to, and 6 times 3 is 18. I need to distribute here, so that'll give me 6x minus 90 is equal to 18. And then I need to add 90 to both sides. So that's going to be 6x equals 108. That's a little bit crooked. 6x is equal to 108. And then I need to divide both sides by 6. And that's going to give me x is equal to 18. Alright, for problem number 5, these similar triangles are nested one inside the other. So I have this small triangle and then I have the larger triangle. Those are the similar figures. I'm going to highlight them to make it more obvious. So here you can clearly see the small inner triangle and the green outer triangle. These two will be similar because of the parallel lines. I'm going to go ahead and call the small triangle the old triangle, and I will call the large green triangle the new triangle. So when I set up my equation, my proportion, as always, I will do new over old is equal to new over old. So you have to be very careful though when we talk about these sides, because a common mistake is to look at this 15 and treat that as the side of the large triangle, but it is not. The 15 is only a portion of the green side that goes from here to here. So 15 should not show up in your equation. 15 is not the side of the new triangle. Instead, you need to understand that if you want to talk about the side of the new triangle, it's going to be the total of these two. So that's going to be 27. Okay? And similarly, let's see, I'm going to go ahead and call this x, where the question mark is, since that's what we're looking for. But when we do this side of the large triangle, it will not be 20. Alright, again, 20 is just this portion of the triangle that goes from here to here. 20 is not the full side of the triangle. So you cannot use a 20. I should not see a 20 showing up in either one of these fractions. Instead, you need to understand that the full side of the green triangle is going to be x plus 20. So when I do new over old equals new over old, okay, the new side is x plus 20. The old side is x. And over here, the new side is 27, while the old side is 12. Alright, so if you can avoid trying to use the 20 or the 15, which is the most common mistake, then you should be okay. I think I will reduce this fraction like I always do, so let's see. 27 over 12. So that's 9 over 4. So that gives me x plus 20 over x is equal to 9 over 4. Time to cross multiply. So I'm going to have the yellow, I'll multiply those, and then I will have the blue, and I will multiply those. So looking at the yellow, I have 9x. Looking at the blue, I have 4 times x plus 20. So that's going to be 9x is equal to distribute. So that'll be 4x plus 80. Subtract that 4x from both sides. So that's going to be 5x is equal to 80. Divide both sides by 5. And you find that x is equal to 16. So that is the unknown side that we were looking for number 5. For number 6, again we have a small triangle inside of a bigger triangle, so let me highlight. So here you go. Like I did last time, I'm going to consider this the old triangle will be the small triangle, and I will consider the large green triangle to be the new triangle. So we are looking for this question mark, which I'm going to go ahead and call x. Okay, so we are looking for that x right there. The unfortunately for us, x is not a full side of either triangle. It's obviously not the side of the old triangle, the red triangle, but neither is it the side of the new triangle. This x only represents the extra length from here to here. So I cannot just use x as a numerator in the problem. So here's the trick that is a little bit hard to understand. We have the length of the full side of the green triangle, and then it sort of is split up into two parts. This part over here is x, and then we have this part over here that is the old side of this triangle. But we need an expression for this, for our equation. So see if you can understand why this side will be, sorry, I'm writing that backwards. If the whole thing is 27 and one portion of it is x, then the other part should be 27 minus x. Okay, can you understand that? If the whole thing is 27, if you start with 27 and take away x, that should leave the other part. Okay, so just I feel like I'm losing a couple people. So here I'm going to have one more shot at it. So for example, if this whole thing is 27, what if I knew for a fact that this was 10? How would you find the other side? If this is 10, wouldn't this other side be 27 minus 10, right? So I could do the same math no matter what this is. So if this is x, alright, if I just go ahead and call this x, then this should be 27 minus x. Alright, hopefully you can understand that. Anyway, now we can go ahead and set up our equation. So we are, as always, setting up our proportion in the form new over old is equal to new over old. Okay, I need a pair of corresponding sides. So 27, alright, let's go ahead and do this side. 27 is the full new side of the triangle. 27 is this side of the green triangle. So 27 is the new. Now, the old is this distance right here, which we just found was 27 minus x, which is why we had to do that, because we needed this. So that's the new, and that's the old. Now, I see some numbers down here. Again, beware, watch out. Do not use the 8. Alright, 8 is only this portion of the side. It is not the old side, it is not the new side, it's just a leftover piece. So when I do my new over old, I must be very careful to do this. Alright? The new side, the green side, is actually going to be 18 because 10 plus 8. Alright, so that's what I'm going to use. I'm not going to use 8. I'm going to use 18. Okay, so a new over old, 18 is the new, the green side, and then 10 is the old. So I'm just going to reduce, so I've got 27 over 27 minus x, and 18 over 10. That's 9 over 5. And now I will go ahead and cross multiply. So I'm going to have 9 times 27 minus x is equal to whatever 27 times 5 is. 135. Okay, I'm going to need to know what 27 times 9 is. 243. So I'm going to have 243 minus 9x is equal to 135. Time to subtract 243 from both sides. This will leave me with negative 9x equals negative 108. And of course, if I divide both sides by negative 9, I find that x is 12. Alright guys, that's going to do it for this video. Go ahead and click here in the red apple to watch the next video. Click in the green apple to subscribe, or click the yellow apple for the full playlist.